Another video of the Sambodhi series, we have already been introduced to a statistical term called central tendency. And there we concluded that the central tendency somehow represents the entire dataset to some extent. But the question here is that is it actually true for all the scenarios? Let's assume, can you actually tell about the career form of a cricket batsman just by looking at his average run? Some might say that yes, we can actually predict that, but statistically, it might not be so. And today, we'll look into this.
Hello and welcome to the Sambodhi series of SETU, where we discuss several basic concepts of statistics, linear algebra, and machine learning. And today we talk about the role of average and consistency. To get to the answer, we assume a situation where in a school cricket team there are three potential candidates: Ramesh, Sonu, and Yadav for a single open slot for an opener. The team coach has the data of their performance in the last 10 matches, and the data looks like this. As we can all see, their total runs and averages are the same. So the coach can't pick the batsman based on their average in previous innings. But due to the present condition, he has to pick just one player for his new cricket team. Now, if we plot an innings versus runs line chart for each individual batsman, we can see that even though their calculated averages are the same, there are definite changes in their distribution. Ramesh and Yadav's runs for each inning seem to vary too much compared to Sonu's. This chart gives us the intuition that Sonu might be more consistent in all of his innings. Now, a question comes to our mind that how can we actually quantify this thing? For that, we are actually calculating the square of the differences for each individual innings from the average. Here, we are actually squaring the difference as we want to measure the dispersion, and one condition might appear when the negative values of the difference might affect our results. Now, after calculating all the differences here, you are actually calculating the average of the squared differences, which would give us the average deviation for each of their innings. We observe that the average of their dispersion for these three batsmen are the following: 774, 88, and 1985. This V here is called the variance of the dataset, and it actually quantifies how much our individual data point is varying from the mean of their entire dataset. Thus, you can automatically conclude that a higher variance indicates that the data points are more spread out from the mean, and a lower variance implies that the data points are more congested around the mean. This shows that Yadav and Ramesh's runs in every innings is deviating much more than the average of Sonu's. So, as for the consistency, the coach can select Sonu as his opener. For future references, we have also given you the mathematical denominations and formulae of the population variance and the sample variance. Now, let us consider an example where there are two batters ranked 4th and 5th respectively, with very low and high means and variances. Let us know what do you think in the comment section below, that whom would you actually pick in your team. Now one can argue that as variance is considering each and every individual data point for the calculation, it can be affected by outliers in the dataset. For this scenario, in a future video of the Sambodhi series, we will introduce the idea of quartile deviation.
Thank you for watching this video till the end, and hope you have grasped the concepts of variance through this video. Feel free to share your thoughts in the comment section below and follow this series for more videos on different topics of the data world.